everyone, my name is Kathy, and today I'm going to work on a physics problem with you. So let's get started. I like to use my iPad, so I'm going to go ahead and share my screen and pull up my iPad. Just gives me a little more flexibility. Okay, so the problem that we are going to work on today involves a block sitting flat on a table. And that part is really important, the fact that it's sitting flat. We are also told that is being pulled on with some force, I'm just going to label that F, at some angle beta that it makes with the table. So this is the general setup, and we are asked to compare how does the normal force compare to the weight of the block. So, like all force problems, we are going to start by drawing a free body diagram. So let's go ahead and do that. So I'm going to represent my wood block with a dot, and I like to also sort of sketch in some axes just so I can keep things nice and neat. Okay, so let's go ahead and draw in our forces. So of course, the very first force I'm going to draw in is that applied force that we are told. And remember, we're just going to call it F since it's some applied force, and it is making an angle beta with the table. We also know that all objects on Earth are going to experience a force of gravity which points directly towards the center of the Earth. And that force of gravity is equal to the object's weight. And finally, we have an object sitting on a table. So we know that the table exerts a force as well. I'm going to draw that force straight upwards. The normal force is always perpendicular to the surface. And so there is our normal force. Great. We have no other forces in the problem except for these three. So the next step is to take my applied force and to draw its components in the X and Y direction. So let's go ahead and do that. So I'm going to have an X component here, and we're going to go ahead and label that force. Now, here is angle beta, which is adjacent. So therefore, we know that it's going to be cosine beta. So it's force cosine beta. And we're also going to have a Y component, so one that's going straight upwards. And so this is going to be our applied force. This time, this component, which you can imagine is over here, right, is opposite of beta. So that is going to be sine beta. Perfect. So now we just want to focus on our component forces that are on the axes. Now, remember what I said at the very beginning, that we are told that our block sits flat. So yes, it is being pulled on by this force, but it is sitting flat on the table, which tells me that my block is not accelerating in the Y direction. If it's not accelerating in the Y direction, then I know that the net force in the Y direction is going to be 0. There's no acceleration. So even though I have this X component here, I'm going to go ahead and ignore that and just focus on what's going on in the Y. So let's go ahead and find our net force in the Y. Well, we have normal force upwards. We also have that applied force, so F sine beta. And then countering those two forces is our weight. So that's minus the weight equals 0. All right, remember what we want to do is compare the normal force to the weight. So what I want to do is I want to get weight on the other side of the equation so that I can see normal force on one side and compare it to weight on the other. So I'm going to go ahead and write normal force plus F sine beta equals the weight. And again, all I did was I just moved the weight over here to the other side of the equation. All right, so how does the normal force compare to the weight? Well, we can see that the normal force plus this additional component equals the weight. So that tells me that the normal force has to be less than the weight. Because if it's more than the weight, then the left-hand side of the equation won't equal the right-hand side, right? If the normal force is more than the weight, then the left-hand side would be larger than the right-hand side. And if it helps you, we can go ahead and put some numbers in, right? So let's imagine that the weight is 10 newtons. Now imagine for a moment that the normal force is larger than 10 newtons, right? So the normal force is bigger than the weight. So we put 12 over here. Well, that's a problem, right? Because we need to we need to add in that component, right? So that tells me that the left-hand side would then be much larger than the right-hand side. It can't be equal to the weight either for the same reason, right? So if this is 10 newtons and this is 10 newtons, again, that doesn't work because I still have to add in that component. And again, this has some value to it. So all of a sudden, my left-hand side no longer equals my right-hand side. So none of these work. The only thing that could possibly work is to say that the normal force is less than the weight. And I believe that is choice A. And that is the answer to our problem. So I hope you learned something from this little demo and I solved the problem for you. I hope to see some of you in class and have a great day.